Assalamualaikum and hi. Okay, class. Today we will learn the new chapter in physics, which is chapter 4, form 4, heat. Basically, in this chapter, we have 4 subtopics to cover. So today we will cover the first subtopic, which is the thermal equilibrium. And the second one is specific heat capacity. The third one is specific latent heat. And the last one is gas law. Okay, before we go further with our lesson today, you need to know how to differentiate between heat and temperature. This is a very important thing that you must to know so that it will assist you for better understanding during our lesson today. So, what is heat? Heat is a form of energy and transferred from hot object to cold object. As you know, there are many types of energy in this world. One of is heat energy, or we also known as thermal energy. Total amount of heat is depend on mass, material, and temperature of object. Heat is a measure of the total kinetic energy and potential energy in an object. So when we say the kinetic energy and the potential energy, it will related to movement of particle or molecule in the object. Okay, unit for heat energy is joule. How about temperature? Temperature is the measurement degree of hotness of an object. Okay, temperature is measure average kinetic energy and potential energy in an object. The unit for temperature is Kelvin. When heat absorption increase in the object, the temperature will be rise. And same goes to when an object release the heat or heat energy from its body, the temperature will be drop. This is the comparison between heat and temperature. Okay, heat is derived quantity. The unit for heat is joule or capital J. Heat measure of total kinetic energy and potential energy of an object. There are no specific measurement instrument to measure the heat. Okay, for the temperature is basically its base quantity. The unit for temperature is Kelvin or capital K. Temperature is measure average kinetic energy and potential energy of an object. We can measure the temperature by using thermometer. Thermal equilibrium. So this is the diagram I provide to you to assist you for better understanding and to help you to get the clear picture what I'm trying to explain to you later. Okay, thermal equilibrium is the condition where there are no heat transfer between two objects. That means the rate of heat transfer, heat energy transfer is zero, and the temperature is the same for both objects. So that we can say that the thermal equilibrium is reached when the temperature of two objects is the same. So both objects must be in thermal contact so that the thermal equilibrium can be occurred. Okay, we need to put two objects or both objects in thermal contact so that the heat energy or thermal energy can be transferred from one part to one part, or one body to one body, okay, to others. Okay, the thermal heat will flow from hot object to cold object, okay, and its temperature will be dropped, but for cold object it will gain thermal energy and the temperature will be rise. Okay, refer to the diagram. Okay, we can see there are two containers, which is the hot one and the cold one. When we put these two containers in thermal contact, okay, the heat energy from hot container will be moved to cold, and heat energy in cold container will be moved to the hot. But you must know heat energy, rate of transferring heat energy from hot to cold is faster, much faster compared to cold to hot. Okay, next, please remember thermal equilibrium will happen when rate of heat flow or net heat flow is zero. okay, there are no more transferring. Rate of transferring heat energy is 0. Then we can say that the system already reached thermal equilibrium. Application of thermal equilibrium. So we have 3 applications which related to electrical appliances. These electrical appliances you can be found at your home. Okay, so the first one is oven. When the food is put into the oven, the heat will transfer from the oven to the food. This process will continue until the thermal equilibrium is reached. Refer to the picture, okay? Let's say you put a turkey inside the oven. So you set up a certain temperature, okay? So when you set up the temperature, that means you try to give instruction to the oven to provide a certain heat energy to transfer from the oven to the turkey, okay? Until one time, at one point, okay, the temperature between the turkey, okay, and the oven will be the same, okay, due to the rate of transfer heat energy from the oven to the turkey is the same. So when there are no, okay, there are no heat transfer between the oven to the turkey, we can say that, okay, the system already reached the thermal equilibrium. Okay, understand? Good. So the second one is refrigerator. When the fruit, okay, or meat is put into the refrigerator, the heat in the fruit will be balanced by refrigerator. This process will be continued until thermal equilibrium is reached, so that the fruits and the meats are maintained in a good condition. Okay. The last one is thermometer. Thermometer is usually will be placed in the object. Okay. Usually thermometer will be placed in object or medium so that the temperature of an object will be transferred to thermometer until the thermal equilibrium reach and give exact temperature reading. Thermometric properties. Okay, what is the thermometric properties? The change in temperature of an object will lead to change of certain properties, and this is called as thermometric properties. Okay, so that any change of object is, we call it as thermometric properties. Okay, the change, okay, the effect by temperature. All the thermometric properties are suitable for the construction of thermometer. Okay, thermometric properties affect these 3 things, which is the first one is expansion of liquid, either in mercury or alcohol. Okay, and then change in volume and pressure of gas. The last one is change in resistance of a conductor. So these 3 things is affected when temperature of an object is changed. Okay, so we will proceed about the calibration of thermometer. How to calibrate the thermometer? So in the diagram provide you a formula, okay, that can be used to calculate during the calibration of thermometer. Okay, in the calibration of thermometer, we will pick 2 fixed point or 2 fixed temperature point. Okay, the first one is the lowest fixed point called as melting point, where the ice starts to melt, usually at 0 degrees Celsius. Okay, and then the second one, the higher fixed point called as boiling point, where water start to evaporate. Okay, usually the temperature below 100 degrees Celsius. Okay, so we continue how to calibrate the thermometer. So there are 2 diagrams I provide to you at the left side. Okay, to calibrate the thermometer, the ice point is usually taken to be 0 degrees Celsius. So we can see in the diagram, we put a thermometer inside the ice and ice start to melt. And this is what we call the melting point. Okay, and the right side diagram, we can see to calibrate a thermometer, the steam point usually taken to be 100 degrees Celsius or less. Okay, in the picture, we try to put the thermometer approaching to the water, but not immerse it. Okay, we just put near to the water so that the temperature of steam can be absorbed by the thermometer. So this is what we call the boiling point. So formula of calibration: T equal to L theta minus L0 over L100 minus L0 times by 100 degrees Celsius. So what is the meaning by the symbol? Okay, T stands for temperature of the liquid. L100 length of capillary in centimeter at steam point. Just now I already show you the diagram at the right side. That what we call steam point. L0 length of capillary in centimeter at ice point, which is the left side diagram. And L0 is the length of capillary in cm or centimeter at the temperature. Okay. So we will proceed for example 1. Okay. Please read the question properly. So we will solve it together. Okay. The length of the mercury column in a non-calibrated mercury thermometer is 2 cm when its bulb is immersed in a melting ice, and 20 cm when the bulb is in steam above boiling water. What would the temperature be if the length of the mercury column is 11 cm? So, first thing, you need to list down all the information given by the question. So, 2 cm. Okay, 2 cm is at L0. Okay, because it state that in the question at melting ice. And the 20 cm is L100 because in steam. Okay, what else? Okay, the question also provide you the length of length of mercury column, which is this is the L theta. So we can solve it. Okay, T equal to L theta minus L0 over L100 minus L0 times by 100 degrees Celsius. So we want to calculate the temperature, right? Okay, so L theta 11 cm minus by 2 cm over 20 cm minus 2 cm. Okay, times by 100. Okay, so we will have 9 over 18 cm times by 100 degrees Celsius. So this we can cut it into half centimeter. Actually, the centimeter don't have, already cancel, times by 100 degrees Celsius. So we will get 50 degrees Celsius. The temperature is 50 degrees Celsius. Okay, make sure you know. First one, you need to read properly. Second one, list down all the information given in the question. Okay, please remember to read carefully. Okay, we will proceed. Okay, next example. Okay, the length of the alcohol column in a thermometer is 2.5 cm and 70.5 cm when the thermometer is dipped into the melting ice and boiling boiling water respectively. Find the distance between every 10 degrees Celsius of the scale on the thermometer. So we have right here 2.5 for L0 and 17.5 is for L100, and then this is already give you the temperature. So temperature is equal L theta Okay. L theta minus L0 over L100 minus L0 times by 100 degree Celsius. So just substitute the information. Okay, 10 degree Celsius equal to L theta that we want to find out at the end of the solution. And then we have 2.5 centimeter over 17.5 centimeter minus 2.5 centimeter times by 100 degree Celsius. So bring this to the left side. We will have 0.1 equal to, okay, centimeter over 15 centimeter. Okay, so bring 15 centimeter to the left side will be 1.5 centimeter equal to L theta minus 2.5 centimeter. Okay, so L theta we will get 1.5 times by 2.5 centimeter, and we get 4.0 centimeter. This will be the final answer. Okay, so I already assist you how to solve the problem or the question that related to the thermal equilibrium in calibration of thermometer. Okay, so I hope that you might be able to answer, to solve any kind of question that related to those topic. Okay, okay, and then we will continue our lesson for the type of thermometer. So basically we have 4 type of thermometer, which is the liquid in glass thermometer, thermocouple thermometer, resistant thermometer, glass thermometer. Okay, usually we use in the lab is the liquid in glass thermometer. So characteristic of liquid use, what type of liquid that we use inside the thermometer. So this one. Okay, liquid in glass thermometer works on the principle that liquid expand as the temperature increase and contract as the temperature decrease. Okay, the most commonly used liquids in such thermometers are basically usually we use these 2 types lah. Okay, the first one is mercury and the second one is alcohol. Usually the characteristic of liquid used in the thermometer is depend on, okay, there are 4 characteristics that we consider to choose. Okay, the first one, easily visible, easy to take the reading. Okay, and the second one, good conductor of heat. This is the very important because the liquid must be so sensitive, okay, to the any change of heat energy, so that we can observe, we can take the reading accurately. Okay, and then expand and contract rapidly over the temperature, and the last one, does not stick to the wall of capillary tube. So comparison between mercury and alcohol in the thermometer. So we have the characteristic that we want to compare between the mercury and alcohol. The first one is the freezing and boiling point, and sensitivity, visibility, thickness, expansion, condition, price, and safety. So this is what we want to compare. For the freezing point and boiling point for both liquid. For mercury, freezing point about -39 degrees Celsius and the boiling point is 357 degrees Celsius. And for the alcohol, freezing point is -115 degrees Celsius. Boiling point is 78 degrees Celsius. Okay. So for sensitivity, mercury have a very sensitive to change of temperature, and for alcohol, react slowly to change of temperature. At this characteristic of sensitivity, we can see that mercury is more efficient compared to the alcohol. For the visibility, mercury easy to read due to mercury color. Okay, and for the alcohol, alcohol is a colorless liquid and need to be dyed. Okay, so much easy to use the mercury compared to the alcohol because mercury have its own color that easy to take the reading. Okay, stickness. Mercury does not stick to capillary tube, but for the alcohol, it will stick to the capillary tube. Okay, expansion. Mercury expands uniformly to change of temperature, but for alcohol, expands slowly and not uniform. So, as expansion characteristic, we can say that mercury much better compared to alcohol. And the condition of mercury does not wet the tube. Okay, it's almost all the time, dry all the time. Okay, and then for the alcohol, the tube will be wet. The price, we can see the price of mercury a bit expensive, but for the alcohol it's the cheaper. And the safety, mercury is very poisonous liquid and can cause the cancer. Okay, affect your health. Okay, and then for the alcohol, safe liquid, but alcohol, you must remember, alcohol easy to fire up. Okay, please remember, please be careful all the time while using the thermometer. Please follow all the instructions given by teachers or lab assistant and make sure your own safety. If not, nah, a bit. Characteristic of thermometer. In this part, we're going to discuss what kind of characteristic that we need to consider before we choose the best thermometer. So in this table, there are 4 characteristics that we need to consider before we choose the thermometer, which one is better. So the first one is the type of liquid. Okay, the type of liquid must be easily expand when the temperature change, so that it will help us to take an accurate reading during the experiment. So the second one is the glass wall bulb. The glass wall bulb must be thin so that heat energy can be transferred easily. Let's say we choose the thicker, so heat energy takes time to transfer from the object to the thermometer. Okay, and the third one is diameter of capillary tube. So the capillary tube diameter must be small for better expansion and good sensitivity for change in temperature. Okay, and the last one is the glass ball stem and the cross sectional. For the glass ball stem must be narrow for increasing the sensitivity. For the cross section or the shape must be curved, so it acts as magnifying glass. So this is the diagram, show the liquid in glass thermometers and the part of component, which is the capillary tube, bulb or glass ball stem, and the scale. Okay, please complete all the tutorials given in my Google Classroom. So that's all for today. Thank you. But duduk rumah diam-diam and jangan degil. Kalau tak, thank you class. Bye.